Good. Today we have, I think, all the hard work done. All the challenges of constraining everything and getting the model put together. It's all done. And last week we went through and looked at how to use Fusion to create the tool pathing. If you remember, and going to assume that I saved, so we could go into this manufacturing tab, and of course I did not. So we don't have any of the manufacturing here, but this is where, from last week, where we spent most of the time in the manufacturing window. Today, in our design space, in our functions here in our workspace, we're going to be working with drawings and taking those drawings out to VCarve Pro. And we're also going to look at using a gadget within VCarve Pro to help with the import of the items. So we're going to kind of see how it goes. I've not used the Dxf import gadget from Vectric for a while, so I might have some relearning to do myself. So welcome, good to see everybody here again today. I think everybody here knows me. I'm Ryan Patterson, ShopBot Tools, and we have a craft table that we have put together in Fusion, and just to review what we have, and also need to make a couple changes to the item that was not approved by the end user or the end customer of the project. So the first thing that we want to look at is kind of the parametrics that we've had with this. So we could, rotate around. And since the last time we spoke, I did add some holes for adjustable shelving. And all 6 partitions are duplicate partitions or cloned partitions. So if we change the size of one or change the whole location in one, they change across the board. Just to view what we've done and how this is all parametric and is done through the user parameters. So we've set up a couple variables, and I'm going to hope that they all just work. I've not actually fully tested this out. So if you remember from day one, we came in and set up a couple user variables in here: material thickness, the width in the X, the length in the Y, and the height. Then we have a bin 1 and bin 2, which I don't know if I implemented those. So we're going to explore those to see if everything is actually implemented and working correctly. So the idea behind this, now that we have this model completely finished, if we've cut this and we realize the customer, whoever it is, doesn't want it to be 40 inches deep, that they want it to be, just 30 inches deep. So I'm going to enter in 30 and then OK. And we could see that that entire model has just been reduced in width, and all parts have been sized accordingly. So that is what parametric modeling is all about, and how it works out for us. The same goes for the width in the X. So if we didn't want it to be 62 inches, now this is where I might get into a little bit of a trouble here with the partition. So we'll just kind of step it down a little bit. So let's go with 50 in the X and see what happens. Yeah, so we can see we're running very, very tight on this partition here. And that is all because of the spacing that we've done, where we've had, I can't remember exactly spacing, but we'll correct that through adding this bin 1 and 2 to the equation and going in for a refresher. So so there's some questions coming in. A few things that we will work on is we will look at how I constrained and created the whole pattern. And it looks like I really messed that up with the sizing of it. So I kind of threw those in last minute. So there isn't something that is not constrained correctly there on those holes. And then we want to add in this bin 1 and bin 2. So let's first look at bin 1 and bin 2 and see where those variables could be used. So I'm going to go into and edit the bottom partition. And remember, we've made the bottom and top a mirrored image of one another. So if we modify one, we're modifying the other. So I'm going to set the option for bottom and check that, saying that that is what we are going to be working with. And the sketch that we have is this one here that has the partitions on it. So I'm going to right click and select Edit Sketch. And this is where we could add in the user variables that I just was looking at. So let's see, bin 1, and let's make the two outside ones maybe bin 1. Now we could get, real fancy with everything here. See what happened right there? That just extended it out beyond. That's okay. Just we'll have to go in and change the. So some of these already are of bin 1 and 2, and we know that by the FX. In front of the dimension. So we've now just constrained and added the user variable for bin 1 and 2. So what that now allows us to do, if we do create a size that throws out the location of those bins or those partition spacing, we now have a user parameter that we're able to, change the value. Go back into user parameters, and I might have to start all over, talking and trying to do all this at the same time is sometimes challenging. Good thing I'm not chewing gum. I might be in trouble. All right, so we are scaled back out, and now let's see if changing any one of those other parameters for the bin is going to give us a different fit. And if it doesn't, we're going to pay closer attention to what that message is that's popping up. So we are in troubleshooting stages at this point. So I'm going to go back in, change a parameter again. Let's take that one to, let's bring it down to 10 and see if anything happens. So here we go. We're getting a warning here that sketch 3, something's failing. So let's figure out what that is all about. So that is something is failing in this sketch 3 on the bottom. So let's go back in to modify and edit that sketch to see what is going on. So we are going to delete as it says to do. And it looks like I had a duplicate dimension on top of one another. So let's try that dimension again. That's looking like we are back on track. I think what has happened is when I made that one too small, or yeah, the width too small for it to fit, I think it just really got it confused on what I was trying to do with it. I could put in construction lines here too, or yeah, construction lines here as well, and just use an equals constraint, or just do a multiple dimension that I'm doing here. All right, so now that we have that corrected, let's bring everything back into a manageable size again. So back into the user parameters, bring the X down to 60 and go up to 36 there. And I'm going to change some other parameters around. Looks like we really did not pay close enough, or I shouldn't say we, I did not pay close enough attention to some other aspects of the constraining there. So we'll dig back into seeing what just happened right there. That is, again, on sketch number 3. In deleting a dimension line, I also had deleted a construction line. So it is important to pay attention to any blue colored lines within a sketch. So what a blue colored line is saying is that it is under constraint, that we do not have it fully constrained, so that that could still be a movable part. To correct that, I'm going to run in another construction line there, and it is not a construction line, so I'm going to set this option here and click on the line. Select the line and tell it that I want that to be a construction line. Then use a horizontal constraint, and we are now back on track. With having the spacing now being adjusted with the bin size, and also everything else looks like it's functioning. The one other thing that I see that we have to do, and this is I was challenged a little bit with it, with this whole pattern. So let's take a look to see what is going on there. So that is partition 1. Before I get too far, we'll go ahead and click save. The holes are on sketch number 5. So we'll right click and select edit sketch. And I set this up using a hole pattern rather than drawing each individual hole. So I started out, only drew this one hole right here, and then under create, I came down here and made a rectangular pattern. And that is what this little icon right here is saying. So we can double click that, and it brings up the rectangular pattern of all the spacing of the holes, how many I have across the top and bottom. And I did set the width, or the location distance between this set of holes and this set of holes, using our user parameters, and put a little formula and math in there to get that spacing. But what I did not do, as you are able to see, I'm still able to move those off to the side in both directions. So that is what we want to make sure that we are able to set. And let's see if an equals constraint is able to work there to there. And there it is. So now I do have a fully constrained part, and notice that all of these holes are now like black, meaning that they are fully constrained and they cannot move. So when we change the width of this object here, or the overall width, all of those hole patterns should stay in line with one another. So we'll just test that and confirm that that is the case. So let's go back into modify user parameters and change that width down to 30. And they did. So they are now constrained and everything moves and flows the way it should be. Now, the one item that we do have to get rid of after the person we're creating this for, or I'm creating this for, said that she liked the idea of the curved edges here as far as being like a safety feature, but they are not going to work for what this table is being designed for. So it is a craft table. And in laying out crafts, if it be fabric or whatever it is, you know, laying out paper or cardstock or poster board, it is always nice to have a square edge to be able to lay and align your work to. So these corners should not be rounded, they should be square. And we could delete that. And how we're going to delete that is look across the bottom of your screen. You will have the timeline. Everything that you have ever done from the very beginning is placed in this timeline. So here is the fillets that we produce, and clicking on those, you see that they are highlighted. So we're just going to right click and delete that. We don't want them anymore. So now we are ready to go. There are a few things that I'll spend some time, you know, later on, and we will produce a video of these parts all actually being cut out to show the whole finished product. We are going to have some casters put on here to move around, and probably put some kind of balance toe kick trim around the bottom of it. But as the title has suggested, we're 20 minutes into it and we haven't even started on VCarve Pro yet. So that's where we're going to look right now. And to go from Fusion to VCarve Pro, we need to have Dxf drawings. What we have been working with up until now have been models. Even in the manufacturing side of Fusion, we've been working with the model only. We have not done anything with drawings. So that is another workspace that we are going to focus on. And that is, we have the design, and drawings is down here at the bottom, where we're able to create a drawing from this design. And we have to do it one part at a time. And if we created the drawing at this point, it is going to create a drawing of the whole assembly. We don't want that. We want a individual drawing of each individual piece. So we're able to bring those into VCarve Pro. So I'm going to start with the bottom. And we could right click and choose to create a drawing of this design. So when we right click, it is creating a drawing. We will, I'm going to come back to this. I'm wondering if we wouldn't be able to do multiples at a time, but we will come back to that, but we're going to take it simple and step by step. The sheet size, I'm not worried about this at all, because we're not going to use this title block or any of that. There could be a way to say, you know, just create new, but it really doesn't matter. I'm going to say OK to this. It generates our title block. And then if you see how I have the mouse, that is like the side view or the front view of our design. We don't want the front view, we want the top view. So in the orientation here, I'm going to select to orient it to the top. And there is our bottom part. The other thing we have to pay attention to is the scale. Right now it is 1/20th. We want this to be a 1:1. And that way, when we bring this into VCarve Pro, we will not have to scale the part. So I'm going to change this scale and making it a 1:1. And I'm not worried about where we place it. I'm just going to select it out here and say OK. I'm going to do a sweep select of all of that title block drawing. And now we have the basic drawing of the two-dimensional drawing of our 3D model. We want to output this to a Dxf file so we could import it into VCarve Pro. So under output, going to select output sheet as Dxf. Just going to overwrite one that's already there. As you can see, I've kind of pre-baked it a little bit. We now have a Dxf drawing that we're able to bring into VCarve Pro. And I do apologize, I'm going to be using Aspire, but all the same functions work in VCarve Pro just the same way. So I'm going to create a new file, enter in job size, just as you would any other VCarve file. I'm going to say OK. And now we could do an import of that Dxf, and it is brought in. We will later take a look at a batch import, but I don't want to do that just yet because we want to modify and correct some of the issues that you will have when importing. First, notice that we do not have any closed vectors or any closed shapes. We need to have closed shapes to be able to cut those or cut this. So I'm going to do a sweep select of all the interior parts. And notice we even have a little spot off on the ends. So with that selected, typing the letter J for join and selecting to join that together. We now have that section joined. We are going to run a profile or a pocketing toolpath on this dado here, depending on the width, and the cutter that we have to use is going to decide if it's going to be a profile or a pocket. And to do that, we are going to need to have this dado extended out to the right of our part just a little bit. So what we got a question, will this work in any version of VCarve? Yes, all versions of VCarve import Dxf drawings just the same way.
Ryan, this is Kurt. Are you saying it needs to be extended past the end so that the cutter produces a square edge?
Exactly, yes, yes.
Thanks.
Thank you for the clarification on that. And the way I'm going to do it, there's several ways of doing it. I don't necessarily care how far they extend out, as long as they extend out farther than half the, or extend out more than the radius, or just a little bit more than the radius of the cutter. So I'm just going to use node editing. Select the two nodes on the right. Just use the arrow to bump those over, and then also selecting the nodes on the left side. I'm using the arrows on the keyboard. In this case, I'm going to use the left arrow key that bumps those over to the left. The other thing we need to do is draw a connecting line to connect the rest of this together. And there's several ways of doing this. You could just use the line tool and draw those lines. That will end up putting in a couple extra nodes there. Not that it really matters, but I like to have things fairly clean. So I'm going to do a node edit of this top line section, hover over top of that line and hit the D on the keyboard. That is delete. I know it's a D because when you right click over top of that line, you see that it's saying delete span. That is the shortcut letter D. Selecting that removes that line span. I've right clicked twice. That got us out of node editing to allow me to select the top line, the bottom line, and I'm going to use the option to join with a straight line. Notice that it connected this side. Do it one more time. We now have a complete closed shape that we are able to prepare for cutting. So at this point for tool pathing, it really wouldn't tool path it any different than we would any other project. There is some notes that you would need to take and translate over, and that is the depths. How deep do we want these, material thickness, and all of that doesn't transfer over in a two-dimensional drawing. So we're going to export a couple more items, and then we're going to look at a batch import. This is a gadget that has been around for since the gadgets came around. I think it was one of the first gadgets that existed on bringing in a multiple DXFs at one time, and then we'll take a look at how we could nest those items. So going back over into Fusion, what we have created here now is we have our table main design, and then we have a new untitled sheet. This untitled sheet is the drawing. I don't typically save the drawings if their only purpose is for going to VCarve Pro. I don't save them. I just end up recreating them when we need to cut the same part again. Or if something changes, I'll just recreate the drawing. So I don't typically save the drawings. And the other part that we're going to need is we will need the back. So I'm going to right click the back and create a drawing of that. And actually for the back, well, let's go ahead and do it. I probably wouldn't even go through the stages of creating a drawing for the back. I would just use the, probably just do the measuring tool and draw out a rectangle in VCarve Pro. The keystrokes that I used for joining those lines was the connect line, jump back over into Aspire here, join with a closed vector with a straight line option. Right click and select make create drawing. Changing that scale once more to a 1:1 ratio. All right, so that is the back. I'm going to go to output and create a Dxf drawing. We will call this a back. Again, close that drawing. I do not need to save it. And we want to create a drawing of the partition, or any one of these partitions. They're all the same. So right click on the partition and create a drawing. and changing the view and the scale. Deleting the title block and doing a output to Dxf for this as well. So those are the three main components that we need to be able to fabricate and build this craft table. And I'm just going to close this drawing here, just to view that, yeah, we got one. Top and bottoms are going to be exactly the same, so we only need to output one of those. We have one back, and all the partitions are the same. So we only have, you know, 1, 2, 3 parts that make up the entire table.
So Ryan, looking at the holes on the end partition, it would assume that you're going to have a separate toolpath for the holes, and you'll just decide which panels get holes on both sides.
That yes, that's exactly what will end up happening. And some of the panels I will, you know, drill all the way through, and
Okay.
some I will only drill part of the way through. So the panels, you know, 2 of the panels will be drilled all the way through, and 4 of them will only be partially there. And they are constrained in a way that there is not a top, bottom, front, or back to the panel. So it doesn't matter which orientation, there isn't a mirrored version of it, which you have to sometimes be, you know, wary of and cautious about.
Did I miss the size of the holes? Is that a standard size for cabinet building, I guess, or?
Well, I cheated a little bit. A standard size would be 5mm.
Okay.
But I made these ones 1/4 of an inch, which is also sort of a standard size. More common is 5mm, but 1/4 inch shelf pegs also exist. So I made them 1/4 inch mainly because 1/4 inch cutters are a little easier to come by than a 5mm. And so that's the reason why I chose to do the 1/4 inch.
Maybe off topic. Would this be a case where an air drill might be useful on the CNC if you were doing this in production? Not to.
Absolutely. Yeah, that's
Okay.
yeah, absolutely. For a cabinet maker, if you're a cabinet maker or any kind of this, typically what we're going to use for really any cabinet making really requires 2 bits. It'd be
Okay.
a 3/8 cutter for cutting all the perimeter cuts, any dado type cuts, and then a 5mm bit for any kind of shelf hole drilling. In some cases, you might need an 8mm bit if you're doing like dados and such, but you could always put 2 air drills on the same machine. So there are those options.
All right. Thank you.
Uh-huh. All right. One more thing that I wanted to take a look at is the drawings to see what happens when we click more than one item. So I saw this selection box here. I just wonder if I could select all 3 at one time. And not quite. So it is not going to allow us to, they don't come in separately. So it is giving us a drawing as if it were the assembly. So we wouldn't be able to do that all in one lump output. We still have to create each component individually. All right, so we're going to come back into Aspire.
Brian, this is Kurt again. I'm assuming the drawing tool is way more robust and you could add dimensions and stuff on that. So you could actually print it out for a customer or something of that sort.
Absolutely, and
Okay.
that is, yes, and that's exactly what the drawing function is really intended for, is to
Okay.
create the engineering drawings for, you know, handing out to production, quality control, your customer, and all of that. So that is what the drawings are really intended for being able to print. And that is also why there's that scale factor there.
Okay, thank you.
Uh-huh. All right, so this is, again, I'm going to delete what we have here, and it's kind of starting from scratch. I was looking up in our gadgets, and I saw the Dxf Batch Processor. I kind of forgot all about this function or this gadget. So we're going to see how it works. See if it allows us to select multiples of the same file. So it is wanting us to choose a folder or a directory of where our Dxf drawings are. And let's see, it is in Dropbox folder, trainings, craft table. So I can't open it, but it's just selecting that folder, selecting open. So this is kind of the layout of how these parts are going to come in. They're going to be 3 in a row with a gap of 5 inches. And then there's our drawing space. So that's and I'm going to say, okay. So it says 3 files have been processed, and there has. So there's 1, 2, and 3 drawings that have been brought in. So they're not nested. That is okay, because we don't want them to automatically nest because we need duplicates of all of these items.
Could you explain nesting
Yeah,
or
yeah.
nest?
Yeah, we're going to go through that now. Nesting
Okay,
is a way to optimize material. And before we get into the nesting, I'm going to quickly join all of the items again, just as we did before. See, we're still separated again. And just doing note edit once more and deleting those lines, selecting both of those and going to join. And again, a node edit to bump that out just a little bit so we could see what's going to happen. So now we're going to nest these parts and kind of optimize them for layout. I am going to rotate this side 90 degrees. And the reason for that is because that's how I want it to be laid out for grain on that part. So for nesting is found on the left side. And if you have an older version of VCarve or Aspire, it did not originally have nesting there. I can't remember what version it was included, but it's been in there for quite a while. But anyway, so go ahead and click the Nest button and going to select all the items that we want to be able to nest. So notice that it put a darker line around the outside of all of these parts. So it is seeing, even though these dados are separate drawings or parts of the main, it's looking at that as if it were one part and how it's going to get laid out. So we also need to create a number of copies. So for this bottom, I unselected everything by clicking out off of the parts, selecting just this bottom and saying that I want to have 2 of those. And notice we have a number 2 that's placed right there in the center. I've applied that. Selecting the bottom and saying that I want to have 6 of those. And now it has the number 6. And now I am ready to go ahead and select all of them. And we still have that number 2 and the number 6 that we're going to have 6 sides, 2 tops and bottoms, and 1 back. So we're going to start at the top on the left side for the tool nesting. And the tool diameter that I plan on cutting this out with is going to be a 3/8 cutter. So we need to allow for 3/8. The clearance that I want to have, and you can see the little picture here, how close is the bit going to come to the adjacent part while it's cutting. So I'm going to put the clearance down at a 0.25 or 125, an eighth of an inch, which is going to give us a part spacing of 1/2 of an inch. The border gap, this is how close to the edge of our plywood are we going to allow these parts to get nested. I'm going to set that to be an eighth of an inch, which means that when I go to lay this on the table, I have to be fairly accurate on getting it laid straight on the table, because it's only giving me an eighth of an inch of fudge factor there. Then we have part nesting options. I do not want to have any parts automatically rotated. I want to have them laid out just as they are drawn. I do not want to allow a mirrored option, which in this case, it really wouldn't matter. And then allow parts to fit inside of other parts. Well, in this case, there isn't any of these parts that could fit inside. And what that means is if we had like a picture frame, something else cut out of here, would it allow another part to fit inside? In this case, it really doesn't matter if that is checked or not checked, because parts are not suited for that anyway. The sheet options, we want the nest to start from the lower left and then along the X. So it's going to like try to place them along the X axis first, starting at the lower left and kind of work its way up. And once everything is entered in, we can click the preview button and we could see it is now laid us out on 1, 2, 3 sheets of material. And we could see how it is all there. If we like it, we could just say, okay. If we don't like it and we want to make changes, we would reset that preview and you can make whatever changes you would like to make. And once you've made those changes, select preview again, then selecting okay. I'm pondering the question that was just asked about wondering if you could make a drawing of the flat piece in the manufacturing.
I could, that was my question. And I guess it was when you were trying to figure out if you could export more than one DXF at a time. I just wondered it might be easier to copy and paste them from what we did last week. You know, when they were manufactured.
Yeah, I'm going to say yes, you can, without even thinking about it. Now, it may not be that you create it from the manufacturing, but you can create a drawing of an assembly, right? So you can assemble all of these parts laid out flat, similar to how we did last week. And yes, you would be able to then, since all of those parts are oriented in the same fashion, you would be able to create a drawing of that assembly and have them all be brought in as one DXF into VCarve or Aspire. So yes, that should work. So now we have sheet 1, 2, and 3. Sheet number 2 and 3 are kind of ghosted that we see them there, but we can't modify it. The active sheet is sheet number 1. To make another sheet active, you would double click on the sheet that you would want to make any modifications to. And add any other details to it. So there's a few other things that we have time for now that really makes things a lot faster for toolpathing. Before we even start explaining it, I'm going to talk about layers some. So I'm going to undo, Control Z, and bring us back down to only the 3 items. And I am going to set these to a new layer. So I'm going to right click and move to new layer and give it a layer name. Same thing for the holes. Move to and then selecting the outside perimeters and going to move that to a new layer, and we'll call that cut. We can now see in our layers list, we have our new layers. We could turn those off. Nothing is visible. That clean this up a little bit. I'm just going to right click and delete the layers that we do not have any objects on. I accidentally deleted objects on that cut layer, so thankfully we have undo. I mean, whoever came up with Control Z in the computer world, that is awesome. All right, so there we have 1, 2, 3 layers that represent the 3 different types of cutting that we're going to be doing. So we have the dados, we have shelf holes, and we have the final perimeter on the cut. I just bumped that up into the list, so we're going to do shelf holes, dados, and cut. Not that that really matters a whole lot, but it does help us when we go to toolpath these items. So again, gonna do a sweep select of everything, gonna nest, and those values are still there, the 2 and 6. Preview, then say okay. So now we're going to see the magic of why I wanted to have those on their own layers. And that is done with the selection method of the toolpathing. So normally you would go around and select everything that you would want to have toolpath. I'm not going to use the mouse to select any objects or any of the items. We're going to allow the layer to do that for us. So going into the toolpath, the first one we're going to do is a drilling toolpath. And again, I am going to go against what we talked about earlier and just do the quick, cheap way out and just say I want to have all holes all the way through, just to make it easy. But I think everybody kind of gets the idea of how to toolpath. So here, I don't know the material thickness. I can't remember it. So I could say Z equals, and that's at 0.75. Let's go a little bit deeper of 0.76 to go all the way through. I'm going to cut with a 1/4 inch end mill. I do not need to do any peck drilling. Coming down here to the selector button, which a lot of you may not have ever used this button. So this allows us to select objects based on the layer name. So I want to have all closed vectors and all closed vectors on the whole shelf hole layer. I want to associate this with the toolpath. So it means that when I would go to recalculate, any newly drawn objects on that layer will also be included in the recalculation. And if our Dxf drawing did have depth associated with it, we would be able to pick up that depth from the Dxf file, but this drawing does not have any depth to it. So we'll go ahead and say close here. Calculate. And we can see that toolpath. Gonna go through the same thing for the dados, not going to select it, just doing creating a profile, a total depth of 3/8. Gonna come in and select a 3/8 cutter. Gonna cut on the inside, coming straight to the bottom again, and using the selector to select all closed. I'm going to associate, uncheck the shelf, check the dados. We'll calculate that. And then the final one that we need to do is the perimeter cuts. I'm going to profile toolpath that, cutting to a total depth of 0.76. That same 3/8 cutter, cutting on the outside.
Hey, Ryan, can I jump into the question?
Absolutely.
Do you ever use that separate last pass here to make sure you get good, clean edges on your pieces?
No, I very rarely use that, especially cutting plywood and wood. I mean, no. If cutting aluminum and metals, I might use it, but cutting wood, if you get the chip load and everything correct, and your spindle is square, and you're using right RPMs, feed rates, you're going to get a smooth cut every time.
Okay. Yep. Thanks.
So using the selector, again, associate, unchecking dados, checking that cut. We'll say okay, and I'm going to call this cut and calculate. So we
Brian,
now
this is Kirk. Could I ask a question about cutters?
yes.
So I'm assuming I think I answered my own question, but so when we talk about chip load, the cutter has a defined speed and it's all been decided ahead of time. Do you understand what I'm saying?
Yes.
I mean, you just pick the cutter, but chip load is important for bit life and things of that sort. At least that's what I read. I mean, I'm not an expert.
It is very important. Yes. So yeah, so chip load is a relation between the number of cutting edges on your bit, the feed rate, RPM. With those three items, you will be able to create a chip load. And the chip load is always just made a little, I don't know why they call it chip load. It really should be called like chip size, because what you're wanting to do is produce a certain chip size when cutting. The bigger the chip equals longer life on the cutter, and most of the time a smoother, cleaner edge. So now that we have our three different tool paths set here, and notice that we don't have any of them set for the other sheets, and there could be other ways to make this happen, but the way I know to do it is setting all of these to be visible or checked. And I want to create a toolpath template based on what we have. So save selected toolpath as a template, or I want to save all visible toolpaths as a template. So I'm going to go ahead and set that option, and you would give it a name. You might want to call it cabinets, or because it is more specifically for cabinets. All right, so now here's, if you've not used this before, this is like magic too. This is all parametric. So I am going to delete all of the toolpaths that we just went through. And now we have 1, 2, 3 sheets. I'm going to load a new toolpath template, and just going to load the same one that we just saved and select open. Now it's asking me, do I want to apply this template to all the sheets? Yes, that's exactly what I want to have happen. And if you notice on the left side here now, we have sheet 1, sheet 2, and sheet 3. And 1, 2, and 3 now all have toolpaths that are applied to them. So toolpath templates is a nice, easy, quick way to create toolpaths, especially if you do repetitive operations. And it really could reduce the number of mistakes that are made. So at this point, we are able to just save out each individual toolpaths as we would want them. So I check sheet 1, save those out, sheet 2, and sheet 3, and so on. Hopefully this has all been very useful. I know it has been a long 4-week session on Fusion, and there's probably still a lot more to learn and cover. And I hope you all enjoy Fusion and getting to use it some. But this is kind of the end of today. Any questions that anybody has on what we've covered over the last several weeks?
Yeah, Donald again. I have one. If it's too lengthy, we can skip it. But this came in as a DFX file, so 2D, right?
Yes.
Could you go from Fusion, just bring the 3D file into VCarve Pro and kind of not go through all these intermediate steps of drawings and whatnot?
Well, not really. If we were going to create a three-dimensional toolpath for it, then yes, we'd be able to bring it in that way. But to be able to profile cut, we need to have the actual lines and edges. So, VCarve and Aspire are not going to see the edge of a model as an edge to cut on. So you can't profile cut. So we would have to then do some tracing and bitmap, overlays and that sort of thing.
Okay, I see. Yeah. I guess the second question I'd ask then is, do you think is it just the tool pathing in VCarve Pro is just that much better than in Fusion 360, that bringing a design from Fusion 360 into VCarve Pro is the better choice than doing the toolpath right in Fusion 360?
Yeah, that's a hard question to really answer because both have benefits. They're just different. Fusion is slowly moving towards, once they get the nesting side in, that's going to be a big savings in being able to use Fusion straight on through. But until then, running multiple sheets this way and toolpathing in Aspire is much quicker. So overall, you want to kind of think about what takes longer. It does take some time currently to lay the sheets out or lay the parts out using Fusion. And then once they are laid out, going around and selecting all the objects that you want to have toolpathed and how you want them toolpathed is kind of time consuming. But if it is a project that you plan on cutting, more than one time and you have varying sizes of it, it might be worth going through and spending the time to do it all in Fusion, because then when something changes, it just all automatically changes. You wouldn't have to re-import or export it or any of that back into Aspire or VCarve.
Great, thank you.
Yep. So the Fusion is free, and there is a free version of Fusion if you are a hobbyist and using it to not make money with it. And that's just, downloading and setting up a user account. They end up following up with you and asking, hey, you ready to buy yet? And I believe you just say, no, I'm just using it as a hobby. And they give you a a hobbyist subscription to it.
That's what I have. It was really easy to do. Just create an account, download it, click the hobbyist button, and they limit you to 10 projects or something like that.
Yeah, and that just started 2 weeks ago, actually, in the middle of our sessions, because the one I opened it up, I was like, what is this? Why is it read only? I was struggled. I'm like, oh, and then I realized that, okay, that was something that they just changed.
Yeah, even that's not very restrictive. It's 10 active projects. So you could have 20 projects and you just click their status, inactive or active. And
Yeah. Yeah, it's very impressive on what you're able to get for nothing, free, and what they provide. It's amazing. It is. I like the cloud-based version of it, and the way you're able to share drawings and such. We don't quite use it yet for. I'm thinking like internally, ShopBot engineering drawings aren't done with Fusion, but it's almost to the ability where we'd be able to draw and model our machines and design engineering machines within Fusion. It's looking better and better every day. Well, thank you all for joining us the last few weeks, and we look forward to seeing you for future sessions of whatever next we decide to present on.
Thanks, everyone. Have a good day.